Hey guys, as you can see I got a little problem here, but who cares? Welcome to the fifth part of the uFrame tutorial. Before we get back to the uFrame, let me explain what's going on. I made a few changes in this scene. We got those buildings in the background with some sort of a parallax effect. We also got this little thingy right here, and I got big plans for this one. When I finish this tutorial, I'm going to make it moving back and forth on the ground, causing additional problems to the player. I also adjusted my camera follow object a bit, so now the game looks a little bit more Space Invaders like, you know. And I also created walls to the left and to the right, and also the ceiling. But any of those changes barely affect the gameplay or the uFrame code. So I will not talk a lot about the details. Instead, let's continue making the game prototype. So what we currently have is this little start game command which generates enemies for us. This is happening in the controller when we fill the Pinky Aliens game enemies collection with newly created enemies. At this point, binding works on the view of the Pinky Aliens game. To be more exact, two bindings work. The first one is that we haven't mentioned here. That's why uFrame default stuff is invoked, and this stuff generates the enemy view for us based on the name of the element. It looks for the prefab with the same name in the resource folder. The second binding we have specified is enemies added, which gives us the newly generated view, and we can place it anywhere we want. So this is my grid, and this is how the enemies look like when they're being placed. Now let's take a look at what's going on with the enemy when we hit him. Here we got this onTrigger catch, which executes hit command on the enemy every time it's being hit with the rocket. At this point in the enemy controller, we got his property is dead set to true, and the corresponding binding on the view right here is being invoked, and we actually destroy the game object, and before we wait a few milliseconds to allow trigger events to work properly. But what's going on with the view model at this point? And what's more important, do we still have this view model in the corresponding Pinky Aliens game collection of the enemies? Because, you know, view got destroyed, so where is the view model? Look at this. Every view is derived from this class called viewBase. And here we got this onDestroy method, which is being invoked when the view actually gets destroyed. So here we see that uFrame has internal references counter for view model objects. So every time we set up bindings on the view, the references counter is being incremented. And every time we destroy the view, references counter is being decremented. So this references counter basically corresponds to the amount of views being bound to this view model object. And then this counter reaches 0, the view model object itself is being unbound. But what does this mean? If you remember, all the bindings which are not related to view are stored in the view model itself. And that's why you can destroy one single view without touching the rest of the system and have its own bindings being unbound. But when we have no views, uFrame assumes that this view model is not going to be used anymore. And that's why the view model object itself is unbound, which means that all the bindings which are stored inside this object are going to be removed. Now, if you look at the Pinky Aliens game view, you can see this little enemies property right here. It corresponds to the amount of enemy view models in the enemies collection, and don't mess those with the views. So as I start killing the enemies, we see that the counter is not being decremented. That means that view models are still in the collection. So we have to twist our architecture a bit to fix this, but there are a lot of ways to do this, and it heavily depends on your design and on you as a programmer. So let's see how we can do this in this case. First, let me modify my enemy view model and replace his isDead property to some sort of an enum called enemy state. And I want those to be alive, dying, and dead. So instead of boolean here, we're going to use this enemy state and rename the property to something sensible. Now let's create another command on the enemy called something like died, I think. Hit save and compile. Now we have to modify our views and a few other things. Let's remove this one for a second. And here, when the enemy is hit, we're going to set his state to dying, so that our view can be bound to this state and actually start producing some sort of a death animation. Now let's go to enemy view and create a binding for the enemy state. Save and compile. Now in the enemy view we got this generated, and here we can do something like this. Let's make display death protected, so it will be available to the child classes of the enemy view. So we will make it virtual, so they can modify the behavior here. And in the end, we want to execute died command. We want to execute this when visually enemy dies. In our Pinky Alliance game controller, we can now subscribe to property of the enemy. And we also want to subscribe to the command. Actually, let's do this later. Here we will change the arguments or their names to enemy and enemy state, so that they make sense. Finally, every time enemy state is changed to, and let me actually use switch. Every time enemy state is changed to dead, we're going to remove him from the collection. At this point, we haven't specified any binding which removes the enemy from the collection visually, so we don't have here on the Pinky Aliens game view we don't have binding called enemy is removed. And if we don't have this, every time our enemy view model is removed from the collection, corresponding view of the enemy is being destroyed by default. So now we know that responsibility to create enemies and their views is on the Pinky Aliens game controller. So it's quite natural to give him the power to destroy the enemy game object. But the enemy's dying effect right here will not destroy the game object itself, but it will only play the animation. So here is the overall picture. Every time our enemy is hit, his state is changed to dying. And let us override died command, so his state is changed to dead. When he's hit, his state is changed to dying, and corresponding binding works on the view right here. If his state is dying, the die animation is played, or whatever you put in your play death method. The only rule, this play death method should execute died when it's finished, or when you think its animation is finished. When this command is executed, enemy controller produces or invokes this died handler, and here we set the state of the enemy to dead. At this point, binding on the enemy view is working, but we don't specify any behavior for this. Then the binding on the Pinky Aliens game controller works, because they subscribe to the property. And here, if the enemy state is dead, we remove this enemy from the collection. At this point, internal uFrame binding works, which you can find in the views, in the Pinky Aliens game view, I think. Pinky Aliens game view base. Yeah, there we go. We don't have a remove handler set. That's why if we go to the binding, we bind to the collection, I think. And there we go. If we don't have a remove handler, object is being destroyed. At this point, the enemy view itself is killed, like completely removed from the game, and all the bindings are destroyed. Also, at this point, if your enemy has only one view and this one is destroyed, then the view model object is unbound itself, so your property on the Pinky Aliens game controller, or the binding to your property, is destroyed because this view model is unbound. Now, if we hit play, we will see our old friend, and we don't like him because it's a bug. As you can see, our enemies get destroyed right away because we execute died method command right away, and in the same frame we got our enemy object destroyed, and that is why trigger events don't work again. So let's fix this. Let's make this a coroutine. Oops. And here we'll yell to return new wait for seconds. For now, let's do something ridiculously small and see if it works. Indeed, we also got our counter here being decremented, which means that enemies are correctly removed from the collection. Here in the view, I got this yield return new wait for seconds set to something small, but to fix the on trigger enter problem, you can just yield return null, which will skip one frame for you. And as you can see, it works absolutely the same way. We just need to wait for one frame before removing the enemy view model to let our rocket trigger event to be executed as well. The reason I use the trigger events actually is because collision requires at least one known kinematic rigid body to be attached to one of the colliding objects, and I have a rigid body on my enemy, but it's kinematic because I don't want it to be affected by the physics. So that's why I'm using trigger events, which do not require non-kinematic rigid bodies. They only require rigid body, but still, this kind of solves the issue. And in order to fix it completely, let's also turn this guy into the coroutine and yield return null, just in case. And here we are going to play the, some sort of an explosion for the rocket, so this one will be useful for us. So now it's time to make our enemies move. That's why we will introduce a new property for our enemy view model, which will be called speed, and we will see a few features uFrame offers us to initialize the enemy view model properly. So now on my enemy, I got the initialize view model turned on, and I have the speed here. I can set it to 3 and apply. Our enemy views are created in the Pinky Aliens game view, but they are created in some sort of internal way, and when they come here, they are not initialized with those prefab settings. If we hit play and generate the enemies, we will see that they have their speed set to 0. And let me set this enemy to active and apply again. So to fix this, we first need to know what's going on. If we go to view base, which is the main base class for all the views, we can look for the start method. There we go. And as you can see here, if our view model object is not set, then we are going to create the model. So when we create our enemies, their view model is already created, so there is no need for this, and this is not invoked. But in any concrete implementation of create model, for example, let's use platform view base here, we call the request view model method, which does a lot of things like blah 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 and blah blah blah. This is exactly what we need, because what it does is that it applies the settings from the prefab, and in any concrete implementation, like for example platform view base, we got properties being set for this platform, which are taken exactly from the inspector. So our conclusion from this is that nothing stops us from going to Pinky Alien's game view, take our newly created enemy and call initialize data on this one and give him the model he has. So in that case, if I hit play and generate enemies, I can see that all of them have the speed set to 3, which is awesome. Now let's go back to our element designer and create one more property for the enemy called direction. And what I don't like about my, setup right now is that I have this little enum called platform direction, and this one represents basically what I want from the enemy. If I add up and down here, but it's named in some sort of inconsistent way, I guess, because it's not pretty much not reusable now. And if I change the name, I will have to modify all the stuff. So let's see what exactly gets modified and what uFrame throws over the fence to us to actually fix. Let's call this mDirection, which stands for move direction. Hit save and compile, and there we go with the errors. So I'm going to take all of those and change them to mDirection. Next, I'm going to fix my bindings. And actually I should do something like find and replace. And do I have this? Well, alright. Replace all. Oh, now let me save this. And voila! Everything should work right now. Let's also generate enemies, just in case. Alright. Now we're good to go with this new reusable enum, and nothing stops me from adding up and down. Save and compile. Cool. So one thing you have to remember is that every time you have a switch, and I'm not sure if we have switch of this type. Let me see the usages. There we go. In case you set movement direction for the platform to something different from what we currently have, then you're in trouble because this argument out of range exception will be called. To fix this, let me replace it. And yeah, I'm lazy, so I got these two things added. Sorry for this kind of delay or whatever, but I just try to keep things as good as possible. So pay attention to those, because I don't remember if we have more switch labels related to mDirection. Now we can link enemy direction to the mDirection. Hit save and compile. And I like to do the things that I can forget about first. So let's go to our enemy prefab, activate this one and set the direction to known, so our enemies appear with known direction set. So now let's go to our enemy view and drop in some code. This piece is very simple. You got this get vector 2 by m direction method, which gives you a vector 2 based on your m direction in terms of unity coordinate system. And here you can see what I call inconsistency. I have to get this left vector by using minus vector 2 right, because vector 2 doesn't have the left, property, but however vector 3 has. So he has all kinds of opposite stuff, left, back, down. I'm not quite sure why couldn't they just put those in vector 2 as well, but who cares. And then we got this update method, which is really simple. We just take the transform of the enemy and translate it using the given vector based on the enemy direction, and you also kick in delta time and enemy speed. And notice how this workflow actually differs a bit from what you do with the bindings. So here we don't need any binding for enemy direction because we're doing something in the update method and only rely on those values. We are not actually interested in the event of changing the corresponding property because it's directly used here, and we do not care really, because if our enemy direction will be changed, our translation stuff will be changed as well, just because it's updated every frame or so. But in case you will want to rotate your enemy, you might want to use the binding, but I won't in this case. We will do fancy stuff a bit later, but right now let's focus on the prototype. So if we go to our game again, hit play, take this only enemy guy and set his direction to something sensible, we will see that things just work. Also, I forgot to cache my transform in the enemy, so let's fix this. Ready. Now it's time to make our Pinky Alliance game controller to actually manage the game logic and make our enemies dance around. Let's create a new public method, which will be a coroutine. And we'll call this start movement, basically, or arrange movement. And for now our game logic will be super simple. First we are going to take all our enemies. Pinky Alliance game, enemies. And we're going to work with those in the while true method, or while true cycle I mean. Actually, it should stop in some way or another, so let's do enemies count is greater than 1. So every time our collection actually becomes empty, the arrange movement coroutine will stop. And also notice that here I extract this enemies list from the Pinky Alliance game, and as far as I know I got the enemies property and not the copy, which is awesome. So I can directly work with those. Because you know, sometimes properties that contain lists can return you something like a copy of the list. So in that case, when your coroutine will work, it will not be updated with what's going on in the real collection, with the real enemies, you know, because you will only have a copy of the list. But right now it seems to be okay, so let's do the following. Move left for 3 seconds, then move right for 3 seconds, but between those, let's move down for 1 second. Finally, we're going to do for each, or basically, yeah, for each of our enemies, in the enemy, I'm going to set direction to right, actually left. Then I'm going to wait for 3 seconds. And this code will basically be the same. Here I will wait for 1 second. Here I will wait for 3 seconds. Move down, move right. Finally, let's start this coroutine. And notice how a controller allows you to start coroutines. So you are usually doing this in the mono behavior, but controllers allow you to start coroutines as well. And later we will see how coroutine commands work. Also, let me clear the Pinky Allen's game enemies every time we start the game. And there we go. And yeah, as you can see, they move left, move right, then move left again. So let's fix this really quick and add something like this maybe. Oh my god, this code is awful, probably, but it kind of makes sense for us right now, so let's skip it. So the cool thing about the enemy container that we can adjust it in the scene like we want, and then generate the enemies using Pinky Allen's game. And if I start game again, I will see that all my enemies were destroyed as we tell it to clear the collection and start. So this is kind of how we can relaunch our game. And maybe you have noticed that we have just invented a new bug in our game. So if we start coroutine for the first time, it seems okay, but as we keep creating more of them, our enemies start to behave in some sort of a very strange and odd way. And this happens because our coroutine actually never stops. So when we clear the enemies right here, they are being filled again, and no way for the coroutine to actually be executed at this point. And that's why the while never sees that our enemies collection has been changed in some way. To fix this, let's dance a bit around the start coroutine method. So if you know, or maybe you don't know, but mono behavior has a stop coroutine method which accepts enumerator, but we only got this stop coroutine which accepts the string name. But what I want to do is I want to cache this guy, I mean this guy right here, to some sort of a field. So I can have this one cached and stop it every time my game is relaunched. But I can do this because we don't have such a method. So let's invent one. Let's go to start coroutine and see what's going on under the hood. And we can see that our coroutine is actually being invoked on active scene manager, which is mono behavior. So that's why we can introduce something like public void stop coroutine accepting the I enumerator. And here we can do game manager, active scene manager, stop coroutine, enumerator. So this is how you can extend things, you know, when you don't have this functionality built in. So don't be afraid to do this. This is kinda way the programming works. You just build upon other things. But I'm not entirely sure that this approach with the coroutine is the best one. So if you know a better approach to stop and, you know, manage coroutines, just use your own, or better let me know so maybe I can fix this. For now we got this stuff working. Let's see if it actually got fixed and our bug isn't there anymore. And we got a null pointer, of course. Oops, I invented the new operator. And there we go. So now let's play around a bit and place our enemies container somewhere here and generate more enemies. 8 by 8, which is pretty much a good number. This game is going to be hardcore, you know. Alright. So time to make some sort of a game over for our game. To make it, first let's go to element designer and to our game system and introduce something like game over. Save and compile. So this game over is not going to be directly executed from the view. Instead, we're going to use some sort of a cross-controller communication. And in our enemy controller, we will override earth reached. And actually, nope, we won't. We don't need more coupling between enemy controller and Pinky Aliens game controller. That's why let's go to Pinky Aliens game controller and subscribe to command. Something like this, I guess. So in case some enemy has reached the earth, we're going to do something like, I don't know, maybe we should just call game over command. So the point of this is that every time you will change the way your logic works, like for example, you will want to execute game over from the view, you will not have to modify anything except the logic itself. So here we can do any stuff, and every time you will decide to, you know, change the things, how the stuff is handled. I don't know how to explain this. You just need to change it to see, but yeah, for now we got this game over executed using another method, which is invoked when a command on the enemy called earthreach is executed. But later you will want to execute this command also when something happens with the Pinky Aliens game view. So that's what I'm trying to say. You won't need to double your code related to game over. So here we can handle all the stuff, like for example execute and start game again. And you know, we don't execute start game command because we don't need this. We're in the same controller, so we can just directly call the method. Now we only need to tweak our enemy to execute this command. Let's do something like if name is earth, then we will do execute earth reached. So the point of this is, like, I'm not trying to show you that this is a good way of doing things. Again, you should think with your own head. I'm just showing you how you can handle different things. You can extract components, you can extract names of objects. And is this a correct way to request the name? Let me see. Just in case I'm going to do this. And yeah, finally, we have to define some sort of a empty object. And add the box2d collider to this. And pay attention to z coordinate. It should be 0, since all of our enemies are in the 0. So we just extend this a bit. Like this. And we call it Earth. Also, we should check that it's trigger. So now if we launch the game, and generate the enemies. We can go make a coffee while they go down. And when we go back, we will see that it works and our game is being relaunched again. Awesome! Now let's go back to our controllers and stuff and just clean things a bit so they look more professional, you know. I'm not entirely sure how to fix this ugly code, but what I definitely want to do is I want to extract this and call it something like this, I guess. Also, I can do this here. And extract this to something called start movement. Also, I want to extract this to something called clear enemies, or clean enemies, or clear enemies. I'm not entirely sure. Let's do clear enemies. And now the code is much more straightforward. And this can be replaced with something like this. So now it's readable. When we start the game, we clear enemies, then add enemy to the battlefield for every single slot we have, and finally start their movement. And each method doesn't depend on the others, except that you have to start the movement after you actually create the enemies, because otherwise when you start your coroutine you will have enemies count 0 here, so it will immediately stop. Awesome so far. And actually let's fix this one too. Let's create a method, private one I guess, and call it something like move enemies, and mention the direction and time. And this one is going to return enumerator too. We're going to set all of our enemies' directions to the direction. And finally, wait for the time. So now all this stuff can be replaced. which kinda again looks much more readable. But it will not work. And now it will. So this is how you can clean up the things in your code and organize your methods a bit. You know, not something that makes things work, but this will keep your code clean so you can easily navigate to whatever part you want. And also, you have to not listen to me first, and secondly, you have to wrap this stuff into the start coroutine. So this is how they work basically. And yep. Now I'm pretty sure that it's gonna work. And I'm happy to announce that my Unity has officially crashed. And yes, I was dumb enough to not save this scene all this time. So here we go, with completely clear stuff. But we still have our enemies working, I hope. There we go. So I wanted to show you effects in this tutorial, but unfortunately it's already an hour long and I don't really want you guys to be overwhelmed with all this stuff. So I'll meet you in the next part where I'm going to recover all this stuff really quick, and we will actually start doing effects and fancy stuff on the screen. See you guys, and thanks for watching.